So a single replacement reaction is when you have one element and one compound in the reactants. These reactions can end up as either no reaction, or they'll make one element and one compound. Now with single replacement reactions, this is the only time you use this activity series. You don't use this in anything else besides single replacement. And reading this, it says increasing activity. So lithium is the most active, and gold at the bottom is the least. That should say least. Now, not every single replacement reaction will happen. For the reactions to happen, the element that is by itself has to be more reactive or higher on this list than the element that it wants to replace. And so let's go through a few examples. Mg plus Ag3N. So when you look at this, Mg is magnesium. Magnesium is a metal. In single replacement reactions, metals want to replace the metal in the compound. So magnesium wants to replace silver, the Ag. You need to go to your list. Magnesium is by itself. And so is magnesium higher on this list than silver? Yes, it is. Magnesium is right here. Silver's down here. So because magnesium, the one that's by itself, is higher on the list than silver, this reaction happens. So now silver is alone, and the magnesium and the nitrogen will form a compound. But you got to make sure you pay attention to your charges when you write this formula. So magnesium, it may be off to the side, right? It is, you go to your periodic table, it's a +2. Nitrogen is a -3. And so that compound of magnesium and nitrogen together becomes Mg3N2. And then we have to balance our equation. There are 2 nitrogens here and 1 over here. So in front of this, I'm going to write a 2. And then now there's 3 magnesiums here, 1 here. So in front of this, I'm going to write a 3. And then on this side, 2 times 3 is 6. So I have 6 silvers. So I need to put a 6 right here. So this reaction written nice is 3Mg plus 2 Ag3N makes 6Ag plus Mg3N2. Okay. Let's do another one. So this time we have magnesium plus lithium chloride. So magnesium is the metal. It's a metal. It wants to replace the metal in this compound. It wants to replace lithium. You go to your list. Magnesium, the element that's by itself, has to be higher on the list than lithium. Well, it's not. Lithium is more reactive than magnesium. So magnesium cannot replace lithium. When the element that's by itself is lower on that list, nothing happens and you write no reaction. And that's it. So that's basic single replacement. We have single replacement reactions with nonmetals. Your activity series is only metals. That's why it says metals. You need to know, and you need to label it on your periodic table. The activity series for nonmetals are that, and the way I wrote it is just like the periodic table. So fluorine is the most reactive, iodine is the least, and you're only ever going to see it with this column, not with the other columns. We don't care about the other columns. So fluorine's the most, down to iodine is the least. But these reactions still follow the same rule. The element that's by itself has to be higher or more reactive than the element that it wants to replace. So looking at this example, lithium bromide plus fluorine. I would look at this, okay, fluorine is the thing by itself. Fluorine is a nonmetal. So fluorine wants to replace the nonmetal in this compound. Fluorine wants to replace bromine. Check, is fluorine more reactive than bromine? Yes, it is. So this reaction happens. Now bromine is by itself, and then the lithium and the fluorine are partnered together. So plus lithium fluoride. Okay, and then to write this equation, lithium has a charge of +1, bromine is -1, so that is LiBr, plus fluorine by itself. Fluorine, you do need to know, is a diatomic element, so when fluorine is not bonded to anything, it is F2. And that will make bromine. Bromine is a diatomic. Over here, it's not bonded to anything, it's alone, so it is Br2. Diatomics only have the subscript of 2 when they're by themselves, not bonded to anything. And then lithium fluoride. Lithium has a charge of +1, and look at your periodic table, fluorine has a charge of -1. So that is LiF. So we've written this equation correctly. Now we need to make sure it's balanced correct. There's 2 fluorines here, 1 on this side. You can't go add a subscript down here because lithium is +1, fluorine is -1. So there's no subscript, it is just LiF. There's 1 lithium, 1 fluorine. But instead, we can put a 2 in front of this, and that's what you have to do. So to make the left side and the right side of the equation equal, you have to put numbers in front. And then now I've got 2 lithiums here and 2 bromines here. So on this side, I need to put a 2 in front, and that's balanced. Okay, we'll do another example. CaCl2 plus I2. You look at your periodic table, I is a nonmetal, so it wants to replace the nonmetal, chlorine. Iodine, the one by itself, has to be more reactive than what it wants to replace. Is iodine more reactive than chlorine? No, iodine's the least reactive. So iodine cannot replace chlorine. So just like before, if this element, it can't replace chlorine, so we just write no reaction. And then we have single replacement with water. For single replacement reactions with water, you might see something like zinc plus water. Anytime you see water, I want you to write it. So water is H2O, you know that, but I don't want you to write it as H2O. I want you to write it as HOH. It's still 2 hydrogens and 1 oxygen, but this hopefully will help you remember what happens. So when you have a metal and water, zinc is a metal. It actually, so on your list, hydrogen is on your activity series for metals. Hydrogen is technically a non-metal, but hydrogen acts like a metal. It has a +1 charge, and all metals have positive charges. So that's why it's in parentheses, but it's on this list. So when you have a single replacement reaction with water, this metal, it wants to replace only this hydrogen, not the other hydrogen. And the reason why doesn't matter, that's just what it does. It replaces 1 hydrogen. And so check your list. Is zinc higher than hydrogen? Yes, it is. So this reaction happens. Now zinc takes the place of just this H. So that H is by itself. And then we have partnered together now zinc and the OH. Those get put together. Now, hopefully OH, you recognize by now, that is a polyatomic ion. It is hydroxide. And OH has a charge of -1. Zinc, you need to know, has a charge of +2. And so that formula would be ZnOH2. Now, I'm not done with this equation. I hope something looks off to you. Hydrogen right here. Hydrogen is a diatomic element. just like fluorine and bromine and chlorine. So anytime hydrogen is by itself, it has to be not bonded to anything, like it is right here, by itself, not bonded. It has to be a 2. And then looking at this, you might say, okay, this equation's not balanced. No, it's not. And I'm going to rewrite it nicer. So we balance this by putting numbers in front. And so on the right-hand side, we've got 2 hydrogens here and 2 here. So that's 4 hydrogens. So over here in front of water, I'm going to write a 2. And now it's balanced. So when you see water, I want you to write it as HOH. The metal just replaces that hydrogen, not the other part of water. And then you end up with that hydrogen out and your metal plus hydroxide. Okay, or if you see it like this, calcium plus H2O, rewrite it. That is calcium plus HOH. And so again, calcium wants to replace this hydrogen. Go to your activity series. Calcium is higher on the list than hydrogen, so this reaction happens. So this hydrogen is out. It's by itself. And again, we write it as H2 over here because it's not bonded to anything. And now we have calcium and OH partnered together. Now, you got to make sure you pay attention to your charges. Calcium is a positive 2. OH, hydroxide, is a negative 1. So that is CaOH2. And let me rewrite this nicer without circles and X's. So it should really be calcium plus HOH makes H2 plus CaOH2. And then we balance this by putting a 2 in front of the water. So those are the 3 types of single replacement reactions you'll see: metals, nonmetals, water.